Hey cat friends, this week I tried designing and 3D printing a helicopter blade for my die grinder. Spoiler alert, it didn't turn out so good. Let's go. Okay cat friends, so why did I decide I needed a helicopter blade for my die grinder? Well, it's because I had one of these as a kid. If you didn't have one, you're missing out. They were like a little helicopter top on a upside down Beyblade launcher. You pulled the ripcord and it launched up into the air. But I'm an adult now. I have a job and responsibilities, so I decided that I needed a really powerful one that spun at like thousands of RPM. And it turns out that's super dangerous and you shouldn't do any of this at home. But the design is really cool. So I had to learn how to make an airfoil because I've never designed one in SolidWorks before. So there's a couple ways I kind of looked at designing this. I was just going to import a picture of a airfoil and kind of trace it, but we've done those in other videos, so that's boring. It's not really accurate. I was going to try and freehand it, but apparently there's lots of math that goes into airfoils. But the way I ended up deciding to do it is using something called an XYZ curve. So XYZ curves in SolidWorks let you input coordinates for X, Y, and Z positioning, and then it creates a curve connecting all those points. But then where do I get the X, Y, Z points for an airfoil? Turns out there's a website for that, so let's go to it. Okay, cat friends, this is the website in question. It is airfoiltools.com. So it's got a ton of airfoil tools if you're really into airfoils. I know nothing about airfoils. I skipped aerodynamics in school to take hydraulics, so I have no idea what any of these do. I chose the NACA 2412 because that was the default one. I know these other ones have different applications, but I just went with the default one, and then I left all my camber, position, thickness, all that stuff just as the default. What I'm really interested here is the DAT file that we have on the side. So these are the XY coordinates. So I'm going to go in and I'm going to grab all of these. I'm going to copy and I'm going to go over to Excel and paste them in. Now we're over in Excel, we're going to paste in the data. So we're just going to click here, drop the data in. But we need to separate this data because it's all in one column right now. We're just going to go over to text columns. So now we have two columns. We have the X column, the Y position, but we have nothing for the Z position. SolidWorks, when you do a curve through XYZ points, it needs a file with X, Y, and Z. So we're gonna have to put something in for Z. I want everything on a flat plane, so we're just gonna make Z 0. And we're just gonna make that 0 all the way down. Perfect. And we're gonna get rid of the XYZ headers because SolidWorks won't like that. Delete. Now we're going to save this out as a TXT file because that's the file type that the curve through XYZ would like. So we're going to save this out and then head over to SolidWorks. Okay, now that we're in SolidWorks, we can finally make our sketch. To do that, we're going to go to Insert and down to Curve, and then we're going to go Curve through XYZ points. So you can see here you could have typed in the X, Y, and Z points manually, but as you've seen in the Excel sheet there's like 81 points for each column, so I don't feel like typing all those in. We're just going to go to Browse and then make sure we're looking for a text file, and we'll grab our airfoil plot. So you can see that SolidWorks is already generating the curve in the screen. We're just going to hit OK, and we got a nice little curve there. Problem is this curve is at too sharp of a tack angle, and it's actually not facing the right way for the rotation. So we're gonna have to kind of manipulate this around. Problem is curves aren't easily manipulated. You can't just flip them around like a sketch. We're gonna make a sketch that mimics this curve, and then we're gonna edit that. So to do that, we're just going to do a sketch on the front plane, and we're gonna convert these entities. We're gonna convert that, check mark, and then we're just gonna break the link between that link right there. We're going to break the link between the curve and the sketch. So now we should be able to move the sketch away from the curve. So now we're actually able to exit out of this and should be able to suppress our curve now. So it's gone. We don't need it anymore. So now we're just going to be dealing with this sketch. We're gonna go here and edit, and we can see that we don't have a closed off end to our airfoil, so we're just gonna close that off with a nice little loop, nice and rounded over, and then we're gonna start making some geometry so that we can actually manipulate this. Okay, now that we got this flipped around, we need to give it the right attack angle. So I did some research into this, and it looks like 15 degrees is the best attack angle for the most lift, I think. So we're going to give this an attack angle of 15 degrees. This is supposed to be engine here. We're gonna put this down here. So now I actually have to offset this a little bit, and you'll see why once we get into this a little bit further. We're gonna do this. This needs to be, what did I say, 15 degrees, I believe? And we're gonna make this horizontal. So there we go, we got a nice 15 degree attack angle, and then we need to scooch this guy over about 3/8. That's about right. And we better give this a solid dimension. Now this is undefined. Always define your sketches. Don't do what I'm gonna do, but I'm just gonna leave it. So next we're gonna extrude boss this out, and we're gonna give this, we're gonna give it a really, we're gonna make it really wide. It doesn't matter because we're going to end up cutting this later into the size we want. This way we're able to adjust that with one feature later on. So we're gonna extrude this out that far. Okay, that's perfect. So now we need to make, this is one wing, but we need to make 3 wings around there, and then kind of the center part and the outside ring. So now we're gonna do the inside point. To do that, we're gonna make a sketch on the top plane. And we're gonna do up 3/4 of an inch. Make this 0.75. And now we're gonna make it go 2 directions. So we wanna make it go this way, and we wanna make it go just below the wing. Make it 1 inch, that's too far. That's too far. That looks good. We're gonna make that go that way a little bit, and then we wanna stick up just a hair, just so it's got a nice bonding area. Make this 1 divided by 8, perfect. There you go. We got a nice little transition into that now. So the next thing I want to do is I want to give this a little bit more shape to it. So to revolve this around, we need to go in and make a circular pattern. We're going to choose this as the circle that we're going to reference around. And then instead of features or faces, we want to pattern the whole body. So we're going to pattern the body 3 times around. And there we go. So now we have actually 3 solid bodies. So we need to combine these together. So we're going to combine. And then we're going to choose our 3 bodies, and they're just added together. So now we're left with 1 body, 3 wings, so we should be good. So now we're just going to make the outside ring. We're going to cut out to the shape, the size we want. So we're going to start with a sketch on the top, and then we need that connecting ring on the outside because I think the blades are going to be too floppy. So on the top plane here, we're going to go with a sketch, circle out, make this, I don't know, 5 inches. And then we're gonna go to features, extrude cut. So we want to cut everything outside that circle. So what we can do is we can go to flip side to cut. We're gonna go bind through all both. We click OK, you can see that everything else was cut away. That's perfect. So now we're just gonna make another sketch to make the actual circle. Once again, go to the top plane, here to here, and then we're just gonna connect this to one of these points here. And let me grab a point. Grab that point right there. On selection. Yeah, there we go. Make those coincident. So now, if we ever wanted to try doing different shapes or different sizes, so when I was testing, I was doing it a bunch of different sizes. I just have to go into that one feature, that one cut feature, and change that in order to change everything with the ring. So that's design intent. So that's thinking ahead on what you want to manipulate later. So we got this. We're just gonna offset it a bit. We're gonna offset it. I think I made it 1/16. That sounds about right. And we're gonna extrude this out. So we're gonna go to, on this way, we're gonna go up to surface. We're just gonna bump it up to there. And then we're gonna go to a second direction and we're gonna go to, we're gonna go to up to surface one more time. And we're gonna go down to there. So now we got everything starting at the right place when we go to 3D print and all the way up. So that's looking good. It's looking like a top. It needs a couple other features though. It needs a pointy top for no particular reason other than it looks better. So I'm gonna skip through that because it's not necessary, and yeah, just extra. Oh, time lapse. There we go, I designed the pointy top. The last thing to design was where the key shaft was gonna go into the bottom that attaches to the die grinder. So this turned out to be the hardest part and the most trial and error. And it's because you need enough friction that the top stays on and gets up to a high enough speed that it produces lots of lift. But it can't be so tight that it doesn't release at all from the die grinder. So it's a lot of trial and error, and I still need to work on this part in order to get it to launch at the right speed. What I ended up coming up with was a, I guess, crescent moon or a half circle on the bottom. So all I did was 0.260 because it's a 1/4 inch shaft, and then cut this in half. Trim this. Cut. And then I made this about, it was actually roughly a 1/2 inch. So I made this kind of half key shaft. I don't know if it was exactly half. It was some trial and error of that because it was just a piece of metal that I ground down flat one side. So I don't think it was exactly half, but this is roughly what it was. So that's it for the design. Now let's go look at the actual build. So the first test started out fairly good, fairly hopeful. There was a young Chris with his die grinder and his spinner. Unfortunately, if you remember me talking about orientating the airfoil the correct way for the rotation, I didn't find out that until after the first test. And my top produced downforce instead of lift. Instead of a helicopter blade, it was just a top. We went back to the drawing boards and flipped around the airfoil. Tests 2 and 3, I was trying to get that connection right between the die grinder and the top, and I couldn't get it to release. So the first one was too tight and the thing wouldn't release, and it just got really fast and really dangerous. The next one was too loose and it just kind of spun around inside the top and it went absolutely nowhere. Test 4 I decided to do in my house, which was the dumbest thing on earth to do. because this was the only test that freaking worked. Test 5, we moved outside. It was nothing above us, it was nothing to hit, so we launched it. Unfortunately, there must have been a defect or there's not enough adhesion in some of the layers, because that thing spun up to 36,000 RPM, I think it is, and instantly exploded. Like, it shot shrapnel like into my neighbor's yard, like at my windows and everything. And that's when I kind of realized that this was way more dangerous than I thought. I don't know if I need to come up with a remote launcher for this or what I need to do, but we're kind of putting it on hold so I don't get actually injured. That's it for today's project, cat friends. I hope you learned something about the XYZ curve. I hope you don't mind me showing you a failed project. Not everything always works the way you want. This one just needs a little bit more refinement. I'm hoping I get time to come back to it because I think this thing could be really cool and unnecessary. Thanks for watching, cat friends. I will see you in the next project.